Assalamu alaikum, this is Junaid Iqbal, and today I'm going to give you a demo video regarding the topic of binomial distribution, and this is for A-level mathematics. So let's just start defining what is binomial distribution. So basically, binomial distribution we normally use when we have fixed number of independent trials, and for each trial we have two possibilities. So for binomial distribution, we have fixed numbers of independent trials, and for each trial we have two possibilities, and these possibilities are either success or failure, and we want to obtain one probability. So fixed number of trials are represented as n, success probability is represented as p, and failure probability as q. And the one probability which we are looking at is the r. So if you want to represent it with the formula, we can write it x equals to r. This is what we are looking for. So it is going to be written as NCR, and I'm going to tell you what is NCR, but it's a combination formula, and we are going to put power of PSR, which is the success, power R, what we are looking, and n minus r to put to the failure. So now NCR is written as n factorial, n minus r factorial, and r factorial. And by the way, if I have to define factorial, so it is like 5 into 5 or into 3. For 5 factorial, it's 5, 4, 3 into 2 into 1. So it's going to be 120 and so on. We can use factorial. So let's take a very small example. Let's say there's a basketball who has a 80% chances of making a successful throw. So let me write basketball player now he has 80% chances of making a successful throw, or what do you say, attempt. So this is going to be P. Okay, so 80% means 80 upon 100, 0.8 is the probability. So if 80% is the success probability, then the remaining would be 20%, 0.2 would be the failure probability. So we have to find the failure probability, keeping in view the success rate. And now the other part of the question is, so they're asking if he makes 10 attempts, like 10 throwing attempts. Now this is going to be the number of trials. So what is the probability that 7 out of those 10 go inside the basket? Okay, inside the basket. This 7 is basically what we are looking at. This is R. So 80% chances of success for every attempt, and definitely 20% failure chances. And number of attempts are 10, and the number of success, which is 7, we are looking for. So if I want to write it based on the formula I mentioned you, this P x equals to R, NCR P to the power R and Q to the power n minus R. So this is basically, so X here is 7. We are looking for 7 attempts which are going to the basket. And NCR means N are the total number of trial, which are 10, and R is 7, which are inside the basket. So P is the success rate, which is 0.8 here, and R is 7, and the failure rate is 0.2, and N minus R. So N is 10 minus R. So this is how we are going to do it. So let's continue. So 10C7 is going to be 10 factorial, 10 minus 7 factorial, 7 factorial, and n factorial, n minus r factorial, and r factorial. So I just put the values. So 0.8 to the power 7 here, and here we will have 0.2 to the power 3. So Px equals to 7, 10 factorial, 3 factorial, and 7 factorial. Similarly, 0.8 to the power 7 would be 0.20, and 0.2 to the power 3 would be 0.008. Okay, so now what we have to do, we're going to cancel whatever we can. So it can be written as 10 into 9 into 8 into 7 factorial. We can write 10 factorial like this. And why I'm writing this? Because I want to cancel this 7 factorial. And by the way, 3 factorial, we do 3 into 2, that would be 6. I'm writing it 6. 7 factorial and 7 factorial would be cancelled. And I'm multiplying 0.20 with 0.008. So it's going to be 0.0016. 0.0016. And now I'm going to just cancel it out. I mean, 3 2 times 6, 3 3 times 9, 2 1 times. So denominator is 1 now, and 5 times. So it's going to be 5 into 3 into 8, which is basically 120. 5 into 3, 15. 15 into 8, 120. Multiply by 0.0016. So let's just continue. So if I multiply it with 0.0016, there's going to be 0.192. So this is how we are going to calculate the probability, and what it is telling, like if a basketball player, that is a skill level, that is chances of success of each attempt is 80%. So failure has to be 20%. So if he's making 10 attempts, and out of those 10, 7 are going to go in the basket. So we are going to put x equals to 7 in place of r. So 10C7, and P 0.8 success rate to the power 7, 0.8, 10 minus r. So this is how basically we are going to solve all these things, and we're going to get the probability of getting the 7 inside the basket if the basketball players has an 80% chance of success, and he is doing 10 attempts basically. So I hope this clears the concept. So let's continue with another question. Okay, let's take this one. This is an interesting question related to dice. So let's see. So a fair die, which has all the dimensions equal, is rolled 5 times. So now this, we are rolling the dice 5 times, means the trial has to be 5, n equals to 5. And find the probability of rolling exactly 2 6. Okay, so 2 6 basically is going to be taken as r equals to 2. Like we are looking for that value. So in this question, we are going to take number of attempts 5, and we are going to take r equals to 2. Now the success rate and failure rate. This is what we need to see. So in terms of dice, getting basically 2 6s, no? 6 numbers. First attempt 6, second attempt 6. So 6 is one event, and out of all the 6 sample space 6. So probability of getting the 6 is 1 upon 6, and probability of not getting the 6 is 5 upon 6, which is 1 minus 1 upon 6. So I hope that is clear. So we're going to use the same binomial distribution formula. So now this is going to be x equals to 2. So NCR 10C2, and success rate 1 upon 6, and this is going to be R, and this is going to be 5 upon 6, 5 minus 2, and then 10 factorial, 10 minus 2 factorial, 2 factorial, and 1 upon 6 square would be 1 upon 36. This would be 5 upon 6, means 5 upon 6 to the power q. This will signify, and this would be 125 upon 260. Now let's just simplify the remaining stuff. So this is 10 factorial, this is 8 factorial, this is 2 factorial, and let me multiply it, all of them. So 1 upon 36 into 125 divided by 216, and I'm going to keep it in fraction. So it's 125 divided by 7776. Now we're going to simplify it. 10 into 9 into 8. 8 factorial to be cancelled. And 2 factorial means 2. 2 1 times, 2 5 times. So it's going to be 45 into that's it. So 45 into 125 upon 7776. So that is going to be probability of x equals to 2, getting 2 sixes. Okay? So 45 into 125 divided by 7776. So I'm going to get this. Or if I want to take it into points, so it would be 0.72. So this is the probability of getting basically 2 sixes if I'm rolling the die 5 times. So I hope this clears the concept. So let's just move towards geometric basically distribution. Now geometric distribution is another interesting distribution. Let me explain first. Now it is also called patience distribution. So basically in binomial distribution, what we did, we have fixed number of independent trials, like how many times you are going to toss a coin, how many times you are going to, roll a die. And for each attempt, we have chances of failure and success. And we are going to obtain number of, things which you want to obtain, like getting 7 inside the box if you are making 10 attempts. So we have two basically events, like chances of success or failures. That's why it is called binomial. Bi means 2. Okay. So now in distribution, geometric distribution, as I told you, it is this is also called a patience, distribution. Now, what it says that we will keep trying. We will, the trial will keep on till we don't get the success, till we don't get our first success. So number of trials here are not fixed. We keep going until success occurs. So we can say that we'll keep trying until first success achieves. Let's understand this. Like here, number of trials are not fixed. We keep waiting for the success basically. I'm going to give you a very, amusing example. So although it's a very, controversial example, but still, I guess for understanding this topic and memorizing it, this will be helpful. So imagine a person, he's proposing to his partner. Okay. So probability of the partner saying is zero point 0.1, let's say. So let's take an example. So person proposing his partner for marriage, and probability of saying yes is only 0.1%. So he's a poor guy, basically 10% chances, 90% rejection chances. So here also, each category, each trial has, success or failure. Like, let's say if they say no for 4, let's say he's tried first day, he tried proposing first day. Here x equals to 1 first day, and he gets no. He gets no. So it's not a success, no success. And he keep trying, and on the 4th day, let's say, he receives yes, very quick, no, very early. So I have to say, now let's say on the 5th day, let's just increase the amount of day. Let's don't get it very cheap. Huh? So on the 5th day, so we will say x equals to 5. We received yes, now it's a success. This is the concept of geometry. We keep on trying. We don't, give up till we get the yes. So what do you say? N try or K try? So let's say it K try. So here K is 5. So you are getting the success in the 5th event. So here also we will have success event, failure event, and let me just write a formula for geometric progression. So here p x equals to k. K is, the success, the number of times, the numbered time which when you get yes for success. So k, so 1 minus p, 1 minus p is basically failure. What you get? 1 minus p is going to be failure. So instead of 1 minus p, let me write q. Okay, so q is going to be power k minus 1. Why I'm writing k minus 1? Because here k was 5 and k minus 1 means 5 minus 1, 4. So in the 4th attempts, he gets no. That is the failure. Okay, and in the last attempt, which is k, he got success. Okay, so this is how we're going to approach these questions. So let's just come out of this proposal scenario and let's go to some example to understand this. Okay, so let's see. This is an example. So defective light bulb. So if you see, probability of a light bulb being defective is 0.05. Find the probability that the first defective bulb found in the third one tested. So the number of attempts are 3, and in the third attempt we find it to be, so here, defective would be, defective is the point of concern. So this is going to be a success event. So here p equals to 0.05. The defective one would be success, whatever is discussed. So the non-defective would be 1 minus 0.05. So it's going to be 0.95. Okay. And here the attempt is third. Okay. So third is going to be the attempt. And now we'll be using that same formula here. X equals to 3. Then we got the success, and qk minus 1. So q is 0.95. The chances of not being defective, and k minus 1 means, so 3 minus 1. I mean, till the second attempt, we are getting the non-defective, the pass, QC pass test. And in the third attempt, we are getting the required, not say required, but the defective one, because we are checking whenever, in which attempt we are getting the defective piece in order to check the frequency or statistics of that. So 0.95 is going to be having the power 2 and 0.05, 0.05. Now, we will just solve it. And let's see. 0.95 to the power square is 0.90 into 0.05. So 0.04 is my answer. So 0.054 is the probability of getting the defective item in the third attempt. Getting defective piece in third test attempt. Okay. So I hope this clears the concept. Let's just try one more example of rolling a die. That is a very good example. Let's just discuss that. So this is going to be my question. So a fair die is rolled until 6 appears. Okay. So find the probability that this happens on the fourth attempt. So probability of having 6, that is going to be the successful event, is going to be 1 upon 6, and probability of not getting 6 would be 5 upon 6, and the attempt is fourth. So here using the probability geometric distribution, so here x equals to, or what you say, k equals to, x equals to k, so x equals to 4 here, and then q, which is 5 upon 6, 5 upon 6, and it's going to be 4 minus 1. So in the 3 attempts we are not getting that 6, and in the last attempt we are going to get the 6. So probability of geometric progression, so 5 upon 6 into 3 to the power q. So let's just solve it. 5 upon 6 the power q into 1 upon 6. So I'm going to get 0.09. So 0.09 is the probability that in the fourth attempt I'm going to get a 6 in the dice. I hope this clears the concept regarding geometric and the binomial distribution. So inshallah I'll come back with another demo video. So this is with regards to A-level physics, A-level IGCSE and A-level EdXL. So let's meet next time. Till then, take care. Assalamu alaikum.